Welcome back to the Cloud Native Platforms track here at Spring One. I'm Whitney Lee. I'm your MC for the second half of the Cloud Native Platforms track today. I'm so glad you're here. There's so much to learn. Next up, we have the passionate, talented Gergely Toth here to deliver his presentation, Peering Inside the Black Box, a Case for Observability. I'm looking forward to learning more about how to use OpenTelemetry to look inside Spring applications and how best to use the information that we discover there. Take it away, Gergely.
Hello and welcome to Peering Inside the Black Box. I'm Gergely Toth. I work for Morgan Stanley. I'm in the Java platform engineering team. And in this session, I would like to take you through the current state of observability regarding OpenTelemetry and the relationship with Spring applications and the Spring ecosystem. So first of all, as our industry moves towards microservices and cloud technologies, it is very crucial to get up-to-date information about what our application or service is doing, what is the amount of resources it consumes, what are the interactions, what is the version, for example, and what is the overall environment that it runs in, because we're moving away from the era where one could SSH into a box and then get some information, which we shouldn't have done anyway in the past. But right now, we shouldn't care actually where our services are running, and but we still require the information regarding what are the resources and what not, and what are the interactions it is doing. As we do not need to reinvent the wheel, we can use the 3 pillars of observability. Just for the sake of confusion, I'm going to be going from right to left and not the other way around. So first of all, we have logs. We all know logs. These are time-stamped record of events. Now, when, for example, the application starts up or the application gracefully shuts down or it doesn't shut down gracefully, we can have some extra information regarding why it didn't do that, and internal error detailed information we log, or we log passwords, as sometimes it occurs. Now, these are individual events being logged by individual services, which is good, but then there is the other pillar, which is metrics, which gives, let's say, a 90 degrees turn in the information, which is more like a numeric representation of measured data. For example, CPU usage, or the disk usage, or the I/O that is being used. Now, as I talked about logs as being individual events in the system, the third pillar is tracing, which correlates these different events coming from the same source outside of our system that relate to each other. So basically, for example, if the application, we have a user that logs into our system, that can affect authentication service, authorization service, and whatnot, where the logs are going to be are not going to be correlated, and with tracing, we can actually correlate these events that come from the same source outside of our system. Sorry, I was jumping a bit. So we have the 3 pillars of observability, and we have logs, metrics, and tracing. So for logs, we use different frameworks and we use different libraries. For example, to aggregate logs, we use Splunk or the Elk stack. For metrics, typically in a Java application or a Spring application per se, we would be using Micrometer or, let's say, Prometheus. For tracing or trace aggregation, we would be using typically Jaeger or Zipkin. Now, as you can see, there are many, many options to achieve the 3 pillars of observability. And we also have some frameworks that provide all of the 3 pillars out of the box, or, as I mentioned, Splunk, for example, only certain pillars of the observability. Now, as we have many, many, many options, and these relate to different frameworks and different libraries, there is need to actually have some kind of standardization of observability and the three pillars, and also what covers the three pillars of observability. So OpenTelemetry came into play, which is a standard solution that provides a common single API for observability. It's also open source and is free to use. And it supports the major programming languages. And let me just highlight that it supports the major programming languages and the major programming languages, because there is a typo there. So if you write your instrumentation code in Python, or you can write it in Python, or you can write it in C++, or you can write it in Java. You write it in a very similar way, and you're using the same API for the common programming languages that we use. OpenTelemetry is extremely easy to use, specifically in Java, because we can add the agent to the JVM, and out of the box, if you use all instrumentation, then the majority of the libraries that we usually use in Java applications will be instrumented. Of course, you need to specify where actually you want to send the data to, as we're collecting observability data, and we need to send it somewhere. And this is when the collector comes into play. So OpenTelemetry has a collector, which is a central place where you can send observability data to: logs, metrics, and traces. Just a side note, that's why it's in parentheses, that logs hasn't been developed yet in OpenTelemetry, at least when I'm talking right now, but it's on the horizon, and metrics is still in a feature freeze phase, and it's basically the SDK is still a draft, but it's getting there. That's why we're going to be focusing more on tracing, because that is the finished part of OpenTelemetry. Now, when talking about traces, and as I said, the different events need to be correlated in different systems. That is when W3C, standard context propagation, comes into play. So the context propagation is a way to send information from one service to the other, which ties the external interaction with our system to one another. So two seemingly individual events in different parts of the system can be correlated. To be able to do that, we need to send some kind of information, and that is when the W3C standard context propagation comes into play. And of course, it replaces the homegrown formats, because for different frameworks, for different libraries, you had these homegrown formats to send this information between services. So just to wrap up again, we're going to be focusing on tracing mainly, because that is the absolutely finished part of OpenTelemetry. But before moving on to tracing and OpenTelemetry, let's step a bit back and look that we had already Sleuth in the Spring ecosystem, which we can think of, if we are just looking at the Spring ecosystem, some kind of standardization of tracing or distributed tracing. Sleuth already hides away the specifics of the framework that we're going to use in the end, which will be Jaeger, Zipkin, or whatnot. So we don't need to think about that. And it's extremely quick to get going with, because you have Spring Initializer, of course, and you just add it as a dependency, you do some very small configuration, and then you're good to go and you're able to send traces. And also, it integrates with other Spring components. So you already have out of the box, majority of the components being instrumented, all of them being instrumented with tracing. And as you can see in the code example, this is what we're really used to in Spring. So we add certain annotations when, for example, we want to create a new span or trace or whatnot. And we don't really want to get rid of this, and we shouldn't get rid of this, as Sleuth is very easy to use and part of the Spring ecosystem. But we also would like to use the standardization of OpenTelemetry. This is when OpenTelemetry Bridge comes into play. So OpenTelemetry Bridge helps you use Sleuth, so you don't have to throw away the code, your favorite code, and you don't have to rewrite your services, but you are still able to use OpenTelemetry. So it basically brings in the best of both worlds. Now, it's currently in incubation. So regarding using it, you need to add snapshot repositories, and then is the place when you can use it. But that will hopefully come out of incubation soon, and then it will be much more easier to use. Now, regarding getting the observability data, usually it's not the developers, well, not but the developers, but one is not interested in this data for the sake of the data. But imagine the Friday afternoon, you're about to close your laptop, and you're about to go to your well-deserved long weekend, when suddenly you get some call that that there is an issue with the service or application you're responsible for. For the sake of the demo, I'm going to be using the well-known Pet Clinic, which is the demo application for Spring Boot. And let's imagine that there is an issue that the find owners, for example, doesn't work all the time. So we cannot find the pet owners in the system. Of course, if you would really get a phone call, then it would be nothing really works. So we would need to figure out what doesn't work. Just to have some more meat in the example, I added Spring Cloud Gateway in front of two Pet Clinic instances. And whenever the user interacts with the system, the Cloud Gateway is going to be routing the call to either of these two Pet Clinic instances. All of the services, the Spring Cloud Gateway and the Pet Clinic, two Pet Clinic instances, are instrumented using Spring Sleuth OpenTelemetry Bridge, and they are sending observability, well, namely tracing information to the OpenTelemetry collector. The OpenTelemetry collector, as it is a central place to process and export data, the OpenTelemetry collector is sending these traces to Jaeger. It is sending its traces to Zipkin as well, just for the sake of it. And it also exposes Prometheus data that it fetches from the two Pet Clinic instances and the gateway itself. Now, all of these three applications or frameworks actually have their own UI, but just to have a single place of where we aggregate all of these, there's going to be a Grafana sitting in front of it, and we will be able to produce nice graphs, and everybody loves nice graphs. So without further ado, let me go to the demo. So here is the Pet Clinic application homepage. Of course, when we get a call that either nothing works or more specifically, the find owners doesn't work, let's do a sanity check before going further. So let's find the owners, and that was expected. So something happened. Now let's refresh to make sure that, oops, and now we actually have data. So let's refresh again and again, and we have some data. So the situation right now is that sometimes the find owners doesn't return any information. It actually fails with some error. Now, let's find out what the issue can be. So as I promised, I have Grafana here. And let's try to figure out what is going on. As I promised, we have one instance of the gateway. We have two Pet Connect instances, which is good. It could be the reason for the failure that either we have one Pet Connect instance or we have 0 Pet Connect instances. I mean, if we have one Pet Connect instance and this is what happens, then maybe the gateway is not configured well, but that is not the case. So we have two Pet Connect instances. We can look at the CPU usage. Nothing extraordinary there. Just as a technical side note, of course, I'm actually running the JMeter that calls the that calls the find owners endpoint in this case. So we can see that we have some activity. Nothing interesting there. We have the gateway memory, which is nice, nice memory allocation. Nothing there. And as you can see, we have the owner repository call rate. So the owner repository in the application, sorry, and specifically defined by last name, which there's a hint that actually is related to the find owners, is actually being called quite frequently. We also have Pet Connect memory, which is, again, nothing extraordinary. So we didn't actually get that much information. Everything looks okay. Everything looks fine. We have some GPA invocation count per second. So there is, let's say, a database access. Of course, it doesn't have to be, but it is a database access. In this case, we have 3 database accesses per second. Now, as we go further down, we can see that we have a success call rate, that is the owners, that is successfully being called. The JMeter is doing its task. And we can see not so good broken heart there. Broken heart is not good. So we have some internal server error, and we also have an alert. Now, of course, the first thing, or maybe in the postmortem, would be to either send an email out with the alert or actually move this alert on the top of the, so we don't have to go through all of this information and instantly see. Okay, so we can see that we have some internal server error, but let's look at tracing if maybe we can find some more information. Let me switch to search. And so here we are able to choose a service. Never mind the Jaeger query. That is actually that I've queried Jaeger already. That is why it's appearing. So let's choose the gateway itself. Let me move this window a bit further down. And then let's run the query. Let's run a query. You can see that we have some traces here. So we can see the trace ID, the trace name, the start time, the duration it took. This is a bit suspicious. But anyway, let's look at a single trace. Let me close this. And let's see what we can see in this one, in this trace. So first of all, we can see that there was a Pet Connect gateway get. That means that there was an incoming HTTP get into the gateway. No surprise there. Let's see what kind of information we can fetch out of this. The owner's endpoint was called. And as we saw, we tried to find the owners, so it actually makes sense. Of course, this was the 200, so this is the happy days scenario. We have a bunch of other information regarding the URL. It was called, and also some process information about the SDK languages, Java and its OpenTelemetry and whatnot. Okay, let's close this. So this was the incoming get call. Now we're going to, as expected, there's going to be an outgoing get downstream. So let's see what information we have there. And you can see that owner's endpoint is called, and specifically the URL is Pet Connect 8080. There's no surprise because this is what the gateway is supposed to do. Of course, we have all the, let's say, usual information as we saw before. Let me close this. And now we're in the other service. We're actually in one of the Pet Connect services, and there is we can see that there is an incoming get. So we can see that this is the client IP, actually the IP of the Pet Connect itself, and who was the caller and whatnot. Nothing interesting here, but here we can see, sorry, I was a bit fast. So basically the next step in the call, here we can see that we have the owner controller. This provides a lot of information because also we have the methods. So it was the owner controller and process 5.1. And we also had a transaction in the very end. And the transaction was commit as expected. So this was the happy day scenario. Let's find something that is more interesting, especially if somebody's calling, because the issue still remains. So let's find, aha. So we actually have some error situations, and you can see the exclamation marks there. So there is an issue. Okay, so as you can see that we have path connect here, most probably the issue didn't happen in the gateway because otherwise it wouldn't have called the path connect itself. So let's jump to the path connect instantly. Aha, and you can see that there is an error true. What else? Status code 500, internal server error, basic error controller. We didn't specify, or I didn't specify custom error handler or controller. And, but here we have some logs, and this is basically shows the correlation between logs and traces. And we can see that we have an illegal state exception, random error. So just because it's Friday night and I'm about to go on my long weekend, no surprise that actually I have the specific method open. And I accidentally added some entropy to the call. So that was typical Friday commit, push, and we can just fix this. So the issue goes away. Now the question is like, how did this made it to production? But that's for a different topic and different talk. So now we're going to build it and release it, of course, with the proper automated tests and whatnot. So we're good to go to our long weekend. But before we do that, let me just wrap up what this session was about. So getting live information about our services is crucial, especially if we don't know and we shouldn't actually care where our service is running, but we require the information what the service or application is doing. So basically to be able to get information upfront to prevent certain things from happening, for example, running out of space. Of course, it is also crucial to find out what the issues were, but I would really emphasize on trying to prevent certain things from happening, as that has extreme benefit to us. There are many options, different vendors, libraries, frameworks that provide observability. And these require specific dependencies, agents, or basically using classes from these specific libraries. OpenTelemetry is a standardization of observability and gives a vendor agnostic solution to getting this data from our services. As we're used to Sleuth as being the tracing go-to in Spring, we don't actually want to change our code, and we shouldn't change our code just to be able to use OpenTelemetry. That's when OpenTelemetry Sleuth Bridge comes into play and provides the best of both worlds for us. Now, what is next up on the horizon? Of course, the finalized Sleuth OpenTelemetry bridge. That way we can add, well, it will be extremely easy to use. We just add the dependency and then we're good to go. Of course, specifying where to send the data. Or if we want to add some extra tweaking, we can do that. OpenTelemetry metrics finalized, as that is in a feature freeze, and also the SDK is in draft, but it's soon to happen. Maybe it even happened during the presentation. OpenTelemetry for logs, that is when we're going to get the 3 pillars of observability, and we can correlate and have nice graphs and find information very, very easily. And of course, just as a bit of an extra, some more metrics, export, and some help basically from Spring regarding OpenTelemetry metrics, as currently there is some basic JVM information, but I'm pretty sure that will change soon. And the same goes for logs. And I really thank you for attending this session, and I hope to see you all in the Q&A. Bye.
Thank you, Gergely, for showing us the importance of observability. Your passion for DevOps really shows. If you have any questions for Gergely, please click the Slack link in the Now Playing tile on this web page. And from the Slack channel, you can find a Zoom link to this presentation's Q&A. By now you know the routine. It's time for another break. Grab a refreshing drink, take a bio break, frost a cake with Josh Long's likeness. It won't be the first one, but it may be the best. I believe in you. Frost like the wind. And I'll see you back here at 3:05 Eastern Time.